Hi guys, today we're going to look at one of the concepts in substitution reaction. And in some of our introductory videos, we have talked about the concept of substitution as one of the processes which are being experienced in organic reaction. Now, apart from this concept of substitution, we have also looked at the concept of elimination, addition, and among others, and of course we have looked at the concept of rearrangement, which is basically going to result in the formation of what we refer to as, sorry for that, isomers. So in this specific case, we're going to look at SN1, that's some kind of a subscript SN1 and SN2. And this basically nucleophilic substitution reactions which are regarded as basically a unimolecular nucleophilic substitution reaction, and this is a bimolecular substitution reactions which I'm going to indicate on the board shortly. So these two types of reactions basically fall under the category of substitution reactions in organic reactions, organic compounds undergo. So therefore I've said that for SN1, this is referred to as unimolecular nucleophilic substitution reaction. Whereas the second one, SN2, referred to as bimolecular nucleophilic substitution reaction, which fall under the category of substitution reaction. And in a sense, we had said that for this particular case, for substitution reaction, this basically entails the reaction whereby we're going to see that one of the atoms that are going to form up, of course, a product is realized due to substitution of another atom that was forming the reacting species. And this kind of reaction occurs on sigma bonds, whereby a sigma bond is particularly undergoes what we call breaking, and it results in the formation of another sigma bond. So if I can just give a general example for this, if we have a species, a chemical species, perhaps a molecule that is like this, that is undergoing a reaction with Y or interacting with Y, this is going to lead to the formation of a product whereby we're going to see that the Z is being replaced by Y in this specific product species, and of course there's a elimination of this atom of Z from this reacting species. So in this particular case, we can see that this particular part is transformed to form this one with the release of this with the joining of this specific reacting part with this specific compound, and then this part of the reacting species is eliminated, and therefore that entails the concept of substitution. So therefore, in a substitution process, we're going to see that the nucleophile replaces this specific part of an atom on the carbon, and of course this can be classified under two categories of what we have referred to as SN1 and SN2 kind of reactions respectively. So we have looked at other examples whereby an organic reaction occurs with the involvement of what we refer to as an intermediate, or intermediate species are going to be formed in between, especially for compounds which are going to be involved in the reaction but have got more than a single step. And therefore for what we refer to as what we refer to as SN2 reactions, which are basically SN2, which are basically we have referred to as a bimolecular. I'm going to use an example to illustrate this one so that we can be able to understand. So I'm going to have an illustration on the board for the same. So in this case, this illustration is going to assist us, of course, understand the concept of a bimolecular nucleophilic substitution reaction. And we're going to note that from this particular case, we're going to have an alkyl halide interacting, of course, with this this we can consider this one to be a nucleophile, and this is going to lead to the formation of an alcohol and this bromide ion that is going to form what we refer to as a living group from this specific reactant species. So in this case, if you try to look at this specific kind of a reaction, we had said that we can be able to illustrate the reaction mechanism for this, and we're going to see that this reactions basically takes place in a single step without involvement also of an intermediate, as I had mentioned, whereby we're going to have this nucleophile attack at this specific point, and this bromide is going to act as a living group to form this specific ion at this particular point. Now we're going to see that this is going to involve a single step, and therefore which we are going to refer to as SN2 kind of a reaction respectively. Now contrary to the SN1 reaction, which is a unimolecular substitution reaction, the unimolecular substitution reaction, which refers to SN1, is going to take place in 3 steps, and this is going to result in the formation of intermediates. So I'm going to give an illustration, of course, which is going to assist us contrast this second part of the SN1 reaction from the SN2 that we have seen above. So in this case, this is a unimolecular nucleophilic substitution reaction. So if you try to illustrate this second example, of course, I'm going to use also another illustration in order for us to understand on this specific concept. So in this particular case, this is going to involve, of course, 3 steps as we had said, and one of the steps that we have indicated at this specific point is the formation of an intermediate. So in the first step, we're going to have this is SN1, whereby we're going to have this particular step proceed, and it's going to be, of course, the first step that is going to lead to the formation of an intermediate. Now in this case, in the first case, we had indicated that this particular point for a bromide, of course, group, which was given us, just going to have a clear illustration for that. The nucleophile is going to attack at this specific point. We talked about the preference for the 3rd degree, 2nd degree, and of course the 1st degree substitutions, or rather reactions, which gives this one in order of preference. So therefore it's going to prefer. So it's going to attack at this, nucleophile is going to attack at this specific point, and this is going to act as a living group. So in this particular case, for the intermediate, we're going to have a bromide group that is acting as a living group at that specific point. And in the second case, therefore, we're going to have this particular water molecule acting as a nucleophile. Therefore, it's going to attack at this specific carbocation at this specific point, and this is going to lead to the formation of what we refer to as this particular case, another intermediate that is having a positive charge at that particular point. There's going to be sharing of electron. Now, in order to stabilize this specific intermediate, and therefore the bromide ion that was acting as a living group is going to pick on one of the hydrogen from this OH2, and that is going to result in this bond moving. Of course, I can just be able to illustrate this. Suppose we have this water molecule that is having a positive charge at this specific point, and therefore the bromide molecule is going to pick on one of the protons, and this is going to move this specific point at the O atom in order to restore stability, and this is going to result in the formation of a OH group at this specific point. Of essence is for us to try and note the chemistry of these 2 specific points for the starting material and the product that is going to be formed. And in our first case, we had the bromide molecule that was being formed, whereas in the SN1 reaction, we're having hydrogen bromide. So hydrogen bromide and an alcohol as the products which are formed respectively. So the involvement of this intermediate basically involves the concept of a SN1 reaction, which is going to involve some number of steps, 3 steps in this particular case, and which leads into the formation of an intermediate unlike the first case for bimolecular, which was just a single step that involved the attack of a nucleophile and an alkyl halide forming the product. So I hope that this is going to assist us in creating the contrast between SN1 and SN2 substitution reactions that we have just mentioned. So catch us in our next video, and whenever we're going to do a reference for this specific type of reactions, I'm going to mention this video and put it in the linking of a description box of other videos which may need us to, of course, elaborate on these two specific concepts. So that is it for now, guys. By kindly go to YouTube and search Honest Sciences and Mathematics TV channel. Subscribe and engage us on the comment section so that we can be able to assist one another in understanding various topics that we tackle in mathematics and sciences. So bye, God bless you.